Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 1 paper from autumn 2023. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 7 to 12, which account for 21 of these marks. Eduqas Component 1 papers are non-calculator papers, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 7a. Simplify 7 root 2 multiplied by 3. So I'm going to work with the integers first. I'm going to do 7 multiplied by 3. I can do that because they're not involved in a square root sign. So that becomes 21. So we have 21 root 2 in total. Part B, complete the calculation below. 2 root 11 multiplied by something equals 22. Well, to complete this calculation, I'm going to do the inverse. So instead of multiplying by 2 root 11, I'm going to divide by it. So I'm going to do 22 divided by 2 root 11. But now we have a surd on the denominator, so we need to rationalise the denominator here. So I'm going to times the top and the bottom by 2 root 11. So 22 times 2 root 11 becomes 44 root 11. 2 times 2 is 4. Root 11 times root 11 is 11. So we have got 44 root 11 over 44. Well, the 44s will simplify out. So this must be root 11. Question 8. Factorise 3xy squared adds 6x squared y. So when we're factorising, we're pulling out the highest common factor and then writing the remainder inside a bracket. Now this expression, it only requires one bracket. Okay, it's not a quadratic expression. Even though we have squares, even though we have powers of 2, we don't have that constant, that number on its own as well to create this. So we're going to have one bracket, but what I'm going to start by doing is writing each of these terms in expanded form. So I'm going to start with 3xy squared. So I can write this as 3 times x times y, because y times y will give me that y squared. I'm going to do the same with 6x squared y, but I'm going to write 6 as a factor pair with 3. So I would do 2 times 3 times x to make the x squared, and then times y. And then this is the point where I'm going to identify what they have in common. So what factors do they have in common? 3, x and y. So 3xy is our highest common factor. So I'm going to write that on the outside of my bracket. On the inside of the bracket, in exactly the same place as the original term is, you write what's left. So instead of 3xy squared, we're going to write y plus, and then instead of 6x squared y, it's 2 times x, which is 2x. So that's that expression fully factorised. Question 9. Hans thinks of a number when his number is multiplied by 2.4 times 10 to the power of 5. The answer is 9.6 times 10 to the power of 8. What number did Hans think of? Write your answer in standard form. So what's happened here is we've had something multiplied by 2.4 times 10 to the power of 5, and it's given an answer of 9.6 times 10 to the power of 8. So to find this missing value, we're going to do the inverse. So instead of multiplying, we're going to divide. So we're going to do 9.6 times 10 to the power of 8 divided by 2.4 times 10 to the power of 5. So I'm going to take it a step at a time. So I'm going to do 9.6 divided by 2.4 to start off with, okay? And to do that, I'm just going to count up in 2.4s. I think that'll be a little bit easier. So 2.4 plus 2.4 is 4.8, plus 2.4 is 7.2, plus 2.4 is 9.6. So we had 1, 2, 3, 4 of them. Apologies for my dogs then. So we have 4, but then we've got 10 to the power of 8 divided by 10 to the power of 5. So I can employ the laws of indices here, the law of division. If I have the same base number and I'm dividing, I can subtract the powers. So this is going to become 10 to the power of 8 subtract 5. So that becomes 10 to the power of 3. Now it wants our answer in standard form, so we need to double check that this is in standard form. So for it to be in standard form, this number at the front needs to be between 1 and 10. Good, it is. And then we're multiplied by 10 to a power. So this is our answer. Question 10. Kate is visiting London. The probability that she will go on the train is 0.4. The probability of Kate going to the theatre is independent of her going on the train. So this means that they have no impact on each other. So she can get the train or not get the train, but she could still go to the theatre or not go to the theatre. The probability that she goes on a train and goes to the theatre is 0.28. Part A, complete the following tree diagram. Okay, so we're going to start with this first set of branches. This is all about whether or not she goes on a train. So remember, the branches on a tree diagram have to add to 1 because probabilities sum to 1. So we can find that missing value by doing 1 subtract 0.4. So that's 0.6. The next step would be to fill these out. But the only information that we know is that the probability she goes on a train and goes to the theatre is 0.28. So going on a train and going to the theatre gives us a 0.28 probability. And what we would have done here is multiply across those branches. So 0.4 multiplied by something equals 0.28. So I'm going to do 0.28 divided by 0.4 to reverse this process. So I'm going to times this one by 100. But because I'm dividing, I have to do the same here. So 0.4 times 100 is 40. So I'm working with 28 over 40 here. I'm going to half it to get it as 14 over 20. I'm aiming to get to a decimal, so I can do that by multiplying this fraction by 5. Because that would give me a denominator of 100. 10 times 5 is 50. 4 times 5 is 20. So that gives me a numerator of 70, which I can read as 0.7. Now that I know the probability that she goes to the theatre is 0.7, the probability she doesn't go to the theatre, as they sum to 1, should be 0.3. And because these events are independent of each other, the probabilities will just be repeated. Part B, calculate the probability that Kate does not go on a train and does not go to the theatre. So does not go on a train and does not go to the theatre. So this is the journey through the tree diagram that we're taking. So the probability that she does not go on a train is 0.6 and the probability she does not go to the theatre is 0.3. When we're moving across those branches, we multiply, and that's what that word and means as well. So we're going to do 0.6 times 0.3. So if I times this by 10, I get 6. Times this by 10, I get 3. 6 times 3 equals 18, but I've got to reverse those things. So 18 divided by 10 and divided by 10 again. So I'm technically dividing by 100. So when I divide by 100, I get 0.18. I find it easier to do it that way, guys, to make sure I have the right number of decimal places than try and guess. Question 11. It takes 2 hours to empty 8 identical tanks of water using 9 identical pumps. How long would it take to empty 2 of these tanks using 3 of these pumps? So we know I like a table to organise my data and my information, so I'm going to write one of those now. So I'm going to work with, okay, so let's have the number of tanks, the number of pumps, and the number of hours or time. So 8 tanks, 9 pumps, 2 hours. We want to know how long it takes to empty 2 of these tanks. So we're aiming for 2 tanks, but with only 3 pumps. Now this is a mixed proportion question. So first of all, I'm working with inverse proportion because the amount of time that it takes 3 pumps to do the same kind of work as 9 pumps, the time's going to go up, but the number of pumps is going down. Okay, so that's an inverse proportion relationship. So if I want to work with 3 pumps within this ratio here, with this within this relationship, I would divide by 3. So when I divide by 3, I need to times my time by 3. So that tells me that 3 pumps would take 6 hours to empty 8 tanks. And that makes sense. Less pumps, more time to empty them, right? But now that we've got this proportional relationship, so it would take the 3 of them 6 hours to do 8, but we're aiming for 2, so we would divide by 4. In this instance, we can divide by 4 on the time as well, because that relationship is directly proportional. The same amount of pumps, less time, less tanks, less time. So 6 over 4 is 3 over 2, which is 1.5 hours. Question 12a. So we've got a grid with shape A drawn on it. Draw the enlargement of rectangle A with a scale factor of 1/2 and centre of enlargement 1, 2. So first thing I'm going to do here is find my centre of enlargement. So across to 1 up to 2. So this is my centre of enlargement here. Now I'm working on this grid in pen, guys. You work on it in pencil in your exam, please, just in case you make a mistake. I just want to make sure that you can see this clearly. Okay, so that's my centre of enlargement. We're enlarging it with a scale factor of 1/2. So there's a couple of ways you can work with this. Okay, we're going to use ray lines to start off with. So I'm going to draw from the centre of enlargement through the corner, through the vertex on the shape. And I'm going to do that for every vertex. You can see the pencil okay, that's not too bad. Okay, so our enlarged shape has got to be somewhere within those ray lines, guys. But it's a scale factor of 1/2, so our shape is going to be 1/2 of its size. We're going to divide all of the lengths by 2. So this point here is 4 across 2 up. Divide that by 2, it will go 2 across 1 up. And if you notice, that then puts it on one of our ray lines. So we're on the right track. Let's check this point. Across 4, up 2, 4, 6. So that would be across 2, up 3. Fantastic. I've drawn my ray lines so that I then don't have to draw, do it for each corner, because I can quite clearly see now that this is where my shape's going to fall from that centre of enlargement. And I'm just going to colour that in so you guys can see it nice and clearly. 12b. So we've got another coordinate grid. Triangle B, which we can see here, is reflected in the line x equals 0 to give triangle C. Triangle C is rotated 90 degrees clockwise about 0, 0 to give triangle D. Part 1, draw triangle C and triangle D. So we're going to carry out these transformations. So triangle B is reflected in the line x equals 0. Well, the line x equals 0 is also the y-axis, because everywhere on that line, x has a value of 0. So we're reflecting it over the y-axis. So this corner here is 2 points away. So it needs to be 2 points away on the other side. This corner here is 2 away. So 2 away on the other side. This corner here is 3, 5. So 3, 5 away on the other side. Complete your shape. Oh, that did not go very well. And then label it as triangle C. Now we're going to do the transformation of triangle C to get triangle D. So we're rotating 90 degrees clockwise about 0, 0. So 0, 0 is here at the origin. And when I'm doing rotations, guys, I'm going to use tracing paper. Now in your maths pack on your exam desk, there should be tracing paper. If there isn't, don't panic, stick your hand up and one of your invigilators will come to you and ask them for tracing paper, because that way we're making sure that we're accurate. So what I've done here is I've traced the shape that I'm rotating. So this is shape C, and I'm going to put an upwards arrow there, and then I'm going to pop my pencil on the centre of rotation, and then I'm just going to turn my paper until that shape has turned 90 degrees. And I know it's turned 90 degrees because my arrow has turned on a right angle on a quarter of a circle. So this is where my shape's going to be here. So there, there, and there. And then we can move the tracing paper out of the way. Complete our shape and label it D. So we've drawn triangle C and triangle D. Part 2. Describe the single transformation that maps B onto D. So going from B to D. Okay, guys? So we're describing a single transformation. So it's as though C never happened. So what would we do to B to get shape D? So first things first, we need to look at the shape. So it hasn't changed size in any way. It's not been enlarged. It could have been reflected or it could have been rotated. So one of the ways to check this, we're going to draw ray lines like we did with the enlargement earlier. So we're going to match up the points on the shape that correspond. So by doing that, those points haven't intersected. And so because they've intersected, it's not a rotation. So it must be a reflection. So what we're going to do here, guys, is I'm going to draw this line in because we want to see which point it's been reflected over. And because it's a slightly different position, it looks to me to be a diagonal reflection, okay? So let's check this point. This point is 1, 2, 3, 4 away from that line. And then it's 1, 2, 3, 4 at a right angle. So this is the line that it's been reflected over. You need to be comfortable with mirror lines and lines of reflection. This is the line y equals x, guys, okay? If it went the other way, it'd be y equals minus x. So by spotting that it's not, these lines don't intersect, so it's not a rotation because there's no center of rotation. It must be a reflection. And because it's not simply a reflection horizontally or vertically, it's got to be on a diagonal line. So that's the first diagonal line that I'm always going to check. Y equals x. So the single transformation that maps B to D is a reflection in the line y equals